Then that's the oxidation state. Okay, come. Let's go through together. Now, first thing, there's a pure element here, I2. Let me put this row underneath oxidation state. Right, Kashan, oxidation state for I2. Good. Anything that is a pure element, OS is 0. Okay, I2 is an element. How about K? Okay, the next one. Which one looks very simple? Well, to me, Ki. Yeah, Ki looks like a simple compound to work on. And Xingyue, okay? Good. Remember, K is group 1 element. And since this is a compound, K will have +1. What about I, Xingyue? Good. Yeah, I'll look at that first. What else? How about this one? Okay, this looks rather simple as well. I mean, the next simpler compound, iron. Why? Yes. Now, guys, quick reminder for iron, if it's not an element, it's either +2 or +3. Okay, that's for secondary school. Either +2 or +3. If it's not in the elemental form. Yep. Remember the rules? The rules also talk about oxygen. Take why oxygen here? Yes, oxygen is -2. Okay, unless it's in a peroxide, then it's -1. But this is not peroxide. This is just a normal sulfate. The last one, sulfur. Take one. And how does he know it's +6? Well, for those who still remember, I use my equation. So what do? I have Fe, I have sulfur, I have 4 oxygen. Okay, I'm referring to this one here. And as a whole, this compound is neutral. So 0 charge. And since I know iron is +2, sulfur is unknown, and I know that oxygen is -2. What is sulfur? If you work out your algebra correctly, you get +6. Oh, just a note, how did Teck Wai know that iron is +2? Well, because this is iron 2 sulfate. I hope you guys know that by now. Okay, so this is iron 2 sulfate. and the 2 refers to the charge of iron, which is +2. Now, lastly, if I work out the last thing here, this one here. Question, iron here, what's the OS? Yeah. Anyway, they also did tell you iron 3, right? So iron 3 means +3. Okay, so the 3 here pertains to the iron. So iron is +3. Question, oxygen. -2. Sulfur, question. Well, there's no change actually. Okay, it's still sulfate. SO4. SO4 is a sulfate, no? All right, so as long as it's a sulfate, sulfur will still be +6. Oxygen is still -2. So guys, what has changed? Hopefully you can figure that out. What has changed? Iron has changed from +3 to +2. So OS decreases. That means this is reduction or oxidation. Good. So where is my oxidation? What else has changed? Why? What else has changed? Yes, good. From +1, iodine has become 0. And this means OS has increased. And by definition, this is an oxidation. Okay, so I repeat, as long as there's a reduction, there must be an oxidation somewhere, and vice versa. Okay, always remember that. Okay, guys, can you try to work out these 2 pages? And in case you didn't notice, there's an absent or missing product. What is that missing product? You should be able to figure out. Okay, there's a missing product X. Bernice, A and B, concentrate. I'll write down for you. Okay, you still must know the answer for this.
Yeah.
What kind of substance is grown? It's one you living in the battery. Yeah. This 5 is pretty much. Yes, it's one thing is the program work it is produced, so that's why the whole make sure that's wrong. Should be able to figure out like this thing. Compare that, compare what something is missing here, compare. Right, something is missing here. Look at the left. Something on the left is not fully represented on the right. What is that? That will give you what X is. It's seldom come up, but still you're so easy. Who has average? I'll give you a hint. A trick, not official one. I just take note of this. This is not officially in chemistry, but it works most of the time. If you can figure out the OS, you can have a good understanding of how the electrons are moving from where to where. Who has gained and who has lost electrons. Correct. But that's provided your OS is correctly worked out. And I'll give you a further hint. It's not again official. Okay, the number of OS that has increased or decreased also tell you how many electrons is gained or lost. Because electron gain and loss is not commonly tested. Everything carefully. Everything on the right. What else is missing? This is correct, but something else on the left is good. There's no right answer. Yes, good. For the second page, they want the state symbols too. Right, so you need to figure out the states of reactants and products. They have some clues for you. You should be able to figure out. Charlotte, try this too. Try the second page as well. Seem to be stuck here. Finish already, yeah? Okay, good. Tell Xingyue, tell me what's the equation here for the second fix? Fe plus F. Oh, sorry, say again. Balance already? And how to balance? Okay, state. Come, guys, look at the clues. Iron, ooh. What state is Wu? Yeah, of course, solid. Have you seen a liquid Wu? No, right? Look at ash. What's the state of ash? Yeah, solid too. Okay, so I mean, unless you are very good in your chemistry, try to spot all these clues. But this one is a bit difficult. Jet. You know, a jet is like a jet of water. But it can also be a gas, right? A flame jet. Yeah, that's a gas. So when you see the word jet, it's either liquid or gas. So definitely not solid. But what else you need to know? Fluorine. Hey guys, what's the formula for fluorine? Take one. F minus. Bernice, fluorine. Formula for fluorine. Well, of course, if you look at it here, they'll tell you F is right at the end there. Okay, they'll tell you F. But guys, don't forget your set 3 stuff. All your group 7. All the group 7. Yeah, they exist as diatomic molecules. So F is F2, Cl is Cl2, I is I2. Please remember that lots of people have made that mistake before. So it's not F, it's F2. And how about the state? Is it liquid or gas? Gas? Each one pick one. Oh, you have already. You have okay. You have okay. Now, of course, everything inside there are elements. Tell me, how many elements are gases in your periodic table? How many are there? How many elements are gases at room temperature, of course? 10? No. Okay, if you remember her stuff, you should have 11 gases. Come, Charlotte, tell us the 11.
Hydrogen, helium, nitrogen, chlorine, neon, chlorine, argon.
You say bromine. Okay, just to get everyone on the same page. I repeat that once. Last column, your so-called group 0, all gases. Group 7, fluorine and chlorine are gases. And the rest will be hydrogen, oxygen, and nitrogen. Okay, then job done. Liquids. Come, Charlotte, how many liquids are there? You didn't?
No.
Yes, guys, 2 liquids only. Make sure you find them on the periodic table. All the rest are solids. I mean, they won't ask you a direct question whether it's solid, liquid, or gas, but it can be part of another question. So if I feel that, why don't you just remember this? And like I always say, in the exam, once you get your periodic table, just write down, unless you think the memory is very great. If not, once you get it, write down on the periodic table, where are the gases, liquids, and liquids. Okay, anyway, back to the question. Yep, that should be your equation. Okay. Next, once you have your equation, look at the OS. What the OS for every element? I mean, I write them down, but yeah, you should really try what are their OS. F2 is an element, so OS is 0. Iron is an element. It's not a compound. OS is also 0. But here, this is a compound. So what's the OS of iron? Known. No need to think so much. The answer is right in your question. They already told you it's iron 3 fluoride. So immediately, the 3 here translates to the 3 there. Okay, I mean, look at all these clues. They have provided a lot of clues here. And fluoride is group 7 element, but now it is in a compound. So OS must be Xingyue. Fluoride. Now, the subscript 3 does not affect the OS. OS is a characteristic of the element itself. Can Xingyue, just be careful. So fluoride is fluoride, which is group 7. So its OS is still -1. Regardless of the subscript here. Okay, so anyway, what do you notice? Come, do your rainbow or whatever you call that. This to -1. OS decreases, so reduction. How about iron? Iron is from 0 to +3. OS increases, so this is an oxidation. And let's go a bit further that I haven't mentioned before, but well, since you're on this question, I shall say that. Look at fluorine F again. Oh, sorry, it's a bit messy already. OS decreased by how many? Decreased by 1. Okay, for fluorine, OS decreased by 1. So that means F has lost 1 electron to become fluoride. Okay. Okay, so OS decreased by 1. It has lost 1 electron. Now, sorry.
Should it be F?
Oh yeah, right. Sorry about that. OS decreased, yeah. My rules there still stand. Has gained 1 electron to become fluoride. Of course, you remember fluoride is F minus, which makes sense, right? F to F minus means gains 1 electron. And by now, you should be able to realize. Oh, morning,
Yeah, morning.
No, this one, OS has increased by 3. So what does that mean? It means iron has lost 3 electrons
You bring me again.
to become iron 3+. So that is the relationship between OS and electrons. But of course, I didn't answer the question. Huh? Why did they say that fluorine is an oxidizing agent? Okay, let me give you the proper answer. Okay, so for the proper answer, let me change the color. Green. Okay, basically fluorine F2 has oxidized. Remember, fluorine is an oxidizing agent, so it must oxidize someone else, right? It's the other guy. And the other guy is iron. From an OS of 0, 2, plus 3 for iron. Okay. I mean, to me, that's the most intuitive way to answer. All right. Fluorine has oxidized iron from OS 0 to plus 3. But the question also asks you for electrons. Fluorine has oxidized iron by removing on this one. Let me rephrase this. By reducing 3 electrons, iron to iron 3 plus. Okay, that is the electron transfer version. Yeah, that's how iron become iron 3 plus by losing 3 electrons. And of course, it's actually removed by fluorine. Questions? Addition? Okay. Now let's look at the page 1 again. Guys, 1A, please remember this brown. Now for secondary school, there are only 2 brown compounds. Okay, only 2. Michelle, what compounds are brown? Oh, okay, what substances are brown? And wow. In this case, iodine is produced, is a product. So yeah, it turns the mixture brown. That's all. That is all. Please remember iodine, please do. It comes up very often. Second substance, which is brown, but not here. It doesn't come up often. I mean, if you can remember it, if not, then hope it doesn't come up. Nitrogen dioxide. Okay, it's a brown gas. If let's say your question tells you the air in the city turns brown, that would be your first culprit or your first suspicion because of NO2. But like I say, it doesn't come up often, not like iodine. Bernice, remember iodine? It turns your air brown. Okay, guys, part B, I really hope everyone gets it. Part B. Alicia, do you get the answer for part B? That's all. Guys, it's potassium sulfate. I hope you notice. Let me clear away the stuff. No, how? I have 3 sulfate here, 3. How many do I have over here? 1 times 2. So there's a missing sulfate. Okay, and what else is missing? I have my 2 potassium missing. So this is your product X, potassium sulfate. And so, I mean, yeah, try to look at all the coefficients and subscripts as well in this case. Hannah, do you get that? Yes. Okay. Of course, make sure formula is correct. Can Charlotte? Formula must be correct. Correct. Okay, good. And I assume you know the spell. I've gone through this already. Okay, electron transfer.
Yes, I agree.
Which element is reduced, Hannah?
Yeah.
Iodine is reduced to iodide. How do you explain your answer, Hannah?
Yeah.
Because
If people don't treat you fairly, you are happy. People treat you fairly, you are positive. So that's and you also
and which reduce.
Okay, never mind. Come. Look at the OS. I2 is 0. I minus is -1. So that is OS has decreased by 1, no? And that means what? That means there's a gain of 1 electron. If you look at my rules in red over there, so therefore, how do you want to answer this using electrons?
And when people go to you, afraid that
Because I has gained 1 electron to become I minus. Oh, but let's go further. Where does the electron come from? Pick one.
Yes.
Let me look again. Oh, okay, maybe I let me double check. Yeah, sorry. I was looking at the other way. It's the other way around for now.
Then you can be yes.
Okay. All right, so basically I minus I is about the other guy. Hold on, let me go back to the basics.
The Germans were first, they were told to take away for the war.
So it's iron
They were
3 plus to iron 2 plus.
the military has to stick even the
Okay, guys, I rephrase my answer.
2 submarines. That's 5 battleships. I don't know. Okay.
Right, so basically iron 3 plus
I don't know.
is
Number 1 and
used to iron 2 plus because iron 3 plus has lost 1 electron to become iron. gain one electron. Okay, yep, double check. Iron 3 plus has reduced to iron 2 plus because it has gained one electron.
This on that at home.
Correct. Wow.
Okay, so yep, that would be the final answer, but where does the one electron come from? Take one. Even though it's 1 mark, but don't have to write this down. However, you should know that where does this come from? Okay, or more exact from iodide.
And if he wants to be in jail, then yes.
Okay, that one electron comes from iodide. And of course, in the process, iodide becomes I2. Okay, I think that about covers it. Any question from anyone? Like I said, electron transfer is not commonly asked, but it's still within your syllabus. So in case it comes up, try to just go back to this, unless you're very clear about your iron 2 plus, iron 3 plus, iodide, iodine, unless you're very clear about that. Otherwise, this would be a good guideline for you to follow. Okay, questions, anyone? No? No? Okay, if not, let me give you another worksheet. Okay, take one. This one for you special. Okay, quick revision. Energy changes, except for take Y, is about exothermic and endothermic reaction. Come, Kashan, tell me what's meant by exothermic. Exothermic. Oh, okay.
Okay.
You say gain heat? Ah, okay. Okay, at the very least, don't screw up this definition. But the second one that's important is also exothermic imply, usually, not all the time, temperature increases. Endothermic, temperature of the system decreases most of the time. So don't confuse these two words. Now, for this case, yep, try to work out the two questions. Take why that one is for homework. The second page for you is for homework. Fine, question. You want homework as well? be careful of boiling. When you boil something, is that something absorbing heat or is that something releasing heat? Think carefully. Okay, same thing for condensation.
I think it's always follow like always keep on slow. I think it's okay at a point where it's start consisting with their body detail and find generally and some updates.
Denise, 2A and 2B. Make sure you get that right.
I think because it depends on how many state it might have positively or negatively affect them. You feel more power or you know, and the question is what you even get all the now for meditation meditation, they spend much time on it. It's not right. You put in any like work that's deep. You work Everybody got to do it. That's like a unintended trend. Then what the doctor reacts on the that's why you are like close to score. Yeah, self cycle to be part of it. Like what we do. They get you know. It's better. Don't say that. I not stop it. I smoke and I eat well. It's
Also, done really. Balance it. You balance. Oh, yeah, you did. Which is correct, no, but you have to balance it. Okay, come, let's go through the balancing part. See, some of you are stuck here. Guys, at the very least, you should be able to write this out. This is aluminum oxide. Make sure you get the formula correct. Hydrogen fluoride, also get the formula correct. It's just like HCl, but you replace the Cl with HF. Now, what is produced? They have already told you aluminum fluoride. Make sure you get the formula correct as well. By now, you should know aluminum is 3+, fluoride is -1. So you need to have 3 fluoride there to balance your aluminum 3+. But the question told you something else is also produced. What is missing? Yes, good. Hydrogen is missing, right? Then oxygen is also missing. Now, oxygen and hydrogen likes to form water most of the time. Right? So just make a guess. 99% you're correct if your answer is water. O and H, because water is very stable when you have O and H together. Charlotte, do you manage to balance it? No. Okay, come guys, make sure you can balance this. I'm pretty serious. What do you look for? First, check for matters. If for those who have gone to my earlier classes, I always look for matter. There's only one matter, aluminum. I have 2 here. I have 1 on the right. Then I just put a 2 here. Okay, so I have 2 here. So I have 1. Make sure you times 2. So I put a 2 in front. Next, what do I look for? Well, normally oxygen and hydrogen will be the last. So what else is there? Fluorine. Oh, you didn't do the fluorine. Yeah, fluorine is not metal. So next I look for fluorine. How many do I have? 1. Yeah. How many? 2 times 3, 6. Okay, I have 6, huh? So what do I do next? Make sure 1 times 6 by putting a 6 here.
I'm scared.
Next, what do I want to balance? Up to you, oxygen or hydrogen? Up to you, but I normally prefer oxygen. So let's look at oxygen. How many on the left, Charlotte? Yes. On the right? 1 only, huh? So how? Times 3. So I put a big fat 3 here. And lastly, I check my hydrogen. I mean, normally that's what I do. Hydrogen, double check. How many on the left? 6. On the right? Yes, job done. Okay, that is my balance equation. Okay, Charlotte. Bernice. Okay, okay, yeah. Try to, I repeat. I mean, you can write down if you want to. Always balance metal first, followed by non-metal. The last will be balancing O and H. Up to you, but normally I balance O first before H. Okay, so yeah, job done. Now let's look at the front part. Now try to get this correct too. Boiling of ethanol, Charlotte. Remember when you boil, ethanol is absorbing the heat, no? It's absorbing the heat. I mean, you can write down if you want to. Okay, so it's an endothermic reaction or endothermic process. Combustion of carbon, Ke-Xuan? Yes. This is the word. Combustion is always exothermic. It always gives up heat. No need to think already. But of course, if you want, this is the reaction.
The same. That's just the
Condensation of water, take Y, is exothermic because water. Because water gives out heat to become, water vapor gives out heat to become liquid water. All right, so that is the tricky part. Condensation is exothermic. Heat is given up so that the water vapor can cool down. How about next one? Formation of water. Now, this one is a bit, wait, not so clear. But look at this. Oxygen gas is involved, no? What do you think is this? What do you think this reaction is? I mean, make a guess. It's possibly a combustion, no? Think about that. And in fact, this is the reaction. Let me use a different color. It's actually what you do when you test for hydrogen gas. You hear that pop sound. That is a combustion. Next one, neutralization. Alicia. The rest all take note. Neutralization is always exothermic. Can look for all these words. Combustion, neutralization. Okay, last one I'll tell you. Sublimation means from okay, it means from solid to gas. What do you think? Venice? Yeah. Okay, the solid absorbs heat to become a gas. So it's an endothermic, or I mean, you can write down if you want, absorbs heat again. Okay, the solid absorbs heat to become a gas, endothermic. Questions, anyone? No? All right, this one is unusual, but let me just answer the last one first.
Yes.
Come, Hannah, tell me, is it endo or exo?
Yes, I think.
Endo. Come, guys. The answer is staring at you right here. Look at this phrase.
I didn't see that.
It's okay. You just lose 2 marks on it. Heat is evolved, no? That means heat is released. That means it's an exothermic reaction. I mean your English must be there. Make sure you know what is the meaning of evolve. Oh, explain. Well, very simple. Just say heat is released. That's all. Okay, now for the last one, which is quite unusual, doesn't come out often. Part C. All right. Why do you get the answer for part C? 7.19. Okay. All right. Of course, you have to calculate the MR. Find out the number of moles of MR. So each mole give out 216 joules. Or 216 kilojoules. Number of moles times kilojoules will give you your actual heat given off. Okay. Question? No. All right. Yeah, take note. The next page for you for your homework. Don't be tricked. Relative formula mass means MR. And because it's ionic compound, so they call it relative formula mass. Before we finish, let me quickly go through the rate of reaction.
You like me?
One good care.
Hey, shit, that people do. My bad.
Okay, rate of reaction, very straightforward.
Me, myself, cannot.
Don't know that I'm having a day.
First, remember your collision theory.
Oh, shit, I'm having a day.
Okay, I'm not going to write it out again. I think you have written that previously. Basically, reactants must collide with enough energy for reaction to occur. Oh, maybe I just write down.
I can get me. Hey, one thing I didn't get. Oh, me. Yeah, awesome. Then what are you? Look,
Okay, so that's the basic. And essentially, there are 4 or 5 factors to speed up a reaction.
I don't push you.
I'm nicer.
But of course, occasionally, the question is about slowing down the reaction. So make sure you can reverse your thinking. Okay, each one give me one. Questions? How to speed up reaction? Increase or decrease?
Increase of all of it.
Your mom.
And temperature is the best because it applies to all reactions. Hey, why? Next one.
You were bad. You are situation. I really
Okay. Applies to.
in the juice. The whites taking juice.
All right. You must have at least one aqueous reactor for concentration to work. Yes.
Both sides decrease.
Oh,
That's solid.
yeah, it's supposed to be. Oh, yeah, you go to that, but they'll know.
Look LC guys, LC. LC guys. It's evil breeders. It's a legal breeders. It's a legal breed guys. Legal breed guys.
Yeah, radio what I got a lot.
Are you sure?
That's kids some more.
Finish? Huh? Okay, pressure increase or decrease? What kind of reactants?
Because I know your mom was a because
You must have at least one gaseous reactant. Let me re-emphasize. I'm only looking at reactants. Products don't come into play. Products will not affect the reaction rate. Or at least not at your level. Anna, one more. Okay. Well, the last one doesn't come up often.
Very fast now.
So catalyst is very specific. For a particular reaction, you only have one particular catalyst. You cannot just add this same catalyst to all types of reactions. So just keep that in mind. Okay. You have time to do this? Huh? Who said no? Okay, tell you what, I'll give this to you next week. And just keep all this in mind. What else? Oh, last point, sorry, one last point. Okay.
all whites. I know what I'm going to I know that one word.
I know it's tedious and troublesome, but you always have to determine what is your limiting factor. It affects how much products are formed. Always keep that concept in mind. Any final questions? No? Okay, then that's all for today. Okay, bye. At least you can manage your equations. Okay, see you. Oh, okay, yes.
DJ.
Okay, thanks for the question. This is not practical, huh?
I know you get distracted. Your team want to be bad like Dia nanti baru kita dan itu ya kelas. Very good. Today is all good Christmas. Hey, what are you? Listen.
Like I say, we've done it before, but it doesn't come up often, but it can still come up. What's the OS? First thing, no oxygen, no hydrogen, right? Don't forget about that. Look at OS. OS. When it's an ion, you have to account for the ion, no? So, what's OS?
Plus two.
Let me see, did they say wrong? There's a typo lah. That only tells you someone. But there's a typo here. I don't know whether you notice. Go to. Oh, by right. That's it. Yeah, you go for your tea.
What?
Yes, thank you. Okay. OS? Anything in OS?
No.
Yes, sir.
Stop.
Is it increase or decrease? Going to 0 is.
Yeah.
We got 2 later.
Yeah, aku tahu.
I mean, this doesn't come often, but it can come up. Especially when it's one vector many. So it can
Yeah,
both increase and decrease at the same time. I think so that is the answer. I mean, that's not clear.
What do you say?
Let's say go one side.
Let's start
And see and C. Have oxidized and removed.
example. Yes. Saya lagi kurang. Dapat result terus. Oh.
That's so powerful oxidizing agent. Okay, that's
I can't trace it.
right. Color change. Yeah. Remember we mentioned for redox, there are two important substances you should know. One is okay, and the other one is potassium permanganate. Is it OA or something? Yeah. So you can't use that, right? Because this is also oxidizing agent. The other one that you must remember too, it's a potassium compound, right? Oh, okay.
Yeah.
Okay. Any no outstanding work, they finish everything like this. So yeah, next week somebody take over. Yeah, thanks for all the work. Okay, all the best, all the best. Anything you can still contact me. Yeah, sure. Yeah, I'll see you around. Okay, all the best. You must remember, it's also a potassium compound. AI. AI is for reducing agent. Try to remember that you can come up for a particular example. So it reduces something else. And then Ki itself is oxidized to what? This one you have to know as well. Because like you say, you want a color change, there's a color change. Ki, what color is Ki? I is a potassium salt. It's colorless. Of course, it's a colorless solid, but you can dissolve it in water to be a colorless solution. No, really, it comes up all the time. Okay, then Ki is oxidized too. Because Ki is a reducing agent, so that means itself is oxidized, right? Not many choices, right? Ki oxidized to I minus is oxidized to not many choices, right? Usually that comes up very often. Basically, can write out. Of course, Ki contains I minus. So basically, I minus is oxidized to I. As I said, this is normally a solution. Colorless. What color is I2? I2? Yeah. So that is the color change. Right. So that's how you can use this to test for your gold oxidizing agent.
So I say add potassium iodide.
Solution. All right. And if it turns brown, then that proves that this is it. Okay, that's okay. I mean, then you just say it turns brown, it proves that this gold 3 is an oxidizing agent. Oh, Alicia, any questions? Oh, okay. Tell me frankly, do you know how to balance equations or not? Got problem, right? Oh, better now. But try to use my method. I mean, unless you think you have a better method, you start by looking at the methods first. Look at the left, look at the right. Okay, if one side is not hasn't enough, then you times by outcome.
Question.
2 questions to try, but you must get the fundamentals correct first now. I mean, trying is okay, but your fundamentals must be there. Like calculations, are you okay with the calculations? More than that concentration, mole per dm cube, gram per dm cube. Okay. Have you done rate of reaction in your school? No.
We just started on Redox.
Oh, okay. Working for you then.
Yeah.
Yeah.
AI into what? Do I have to put this?
Actually, it's the other way. Normally, you add the gold 3 ions into Ki solution. Oh.
Here you go.
Oh, you mean they didn't mark it down?
Yeah. That's